energy is collected through solar cells when photons from the sun strike the semiconductor material, causing electrons to break away from their atomic bonds. Their electrons are forced in one direction, which is what causes there to be an electrical current. The material of a solar cell is silicon, which has semiconducting properties and is usually used in electrical circuits like this one. Build a prototype that maximizes energy efficiency. Our model has a cardboard base that we spray painted with heat protective black paint that will also attract heat and sunlight. We taped the 4 solar cells we were able to use to the 31 by 26 centimeter cardboard frame and punched holes for the wires of each cell. For better support when standing, we glued a thick piece of wood to the back and connected 3 stands that we glued to the back of the cardboard to keep it upright. This way, the sunlight would hit the.
The next learning target was to identify sources of kinetic and potential energy within the system. The sun is a source of potential energy in our solar panel system because its energy is delivered in a form of electromagnetic energy. This form of potential energy is different from the usual definition of energy stored for later. The forms of kinetic energy used in our solar panel are visible light in the solar cells, converting radiant energy into electrical energy. Our next learning target was explain how energy can be converted from one form to another. So energy can be converted from one form to another in multiple different ways. One of the ways is through action of forces. The first way is through gravitational forces. This means that when gravity accelerates a falling object, it converts its potential energy to kinetic energy. Another way is through electric and magnetic force fields. Charged particles with electric fields exert forces possessing potential energy in the presence of an electric field in a way similar to that of an object in a gravitational field. These force fields can accelerate particles, converting a particle's potential energy into kinetic energy. One of the last ways is through frictional forces. So frictional forces are a macroscopic or a large-scale energy of an object. That is the potential and kinetic energy associated with the position, orientation, or motion of the entire object. Not counting the thermal or heat energy of the system can be converted into thermal energy, or heat, whenever the object slides against one another. The sliding causes the molecules on the surface to contact and interact via electromagnetic fields with one another and start vibrating.
We tested our prototype 3 times. Our experiments include seeing how much energy the solar panel collected over a period of 30 minutes, analyzing which direction collects the most sunlight over a period of 10 minutes, how many AC volts we could put into a AA battery over a period of 2 minutes. I will, however, only be talking in depth about our first experiment. We started by hooking up our prototype to this multimeter. Then we set up our makeshift sun and set a timer, recording what was on the multimeter every 5 minutes for half an hour. Our results are as follows. 5 minutes we got 184 AC volts. For 10 minutes we got 612 AC volts. 15 minutes we got 1,335 AC volts. And 20 minutes 3,872 AC volts.
Contact the principal because she oversees everything at the school and knows about the energy bill and how the school would benefit from using solar panels. We emailed Moxie Solar Panel Company to get input from solar professionals. Since they are a Midwestern solar panel company, they would overlook our project and possibly provide us. They gave very useful feedback on saving energy in multiple ways by turning off the lights and turning down the air conditioner with our solar panel. We thought that Moxie Solar Company has gave us really excellent feedback, and we're glad that we got to contact them.